Okay guys, so this is the deep water circulation lab. We already know a little bit about deep water circulation from what we've already learned. We know that deep water circulation occurs below the picnic line, that it involves both horizontal and vertical motion, and that it is primarily density driven. Remember, this is a lot different from surface currents, which are wind driven. So these are density driven. We also know that density is affected primarily by two main factors. Those factors are temperature and salinity. So as we increase temperature, we're going to decrease density. And conversely, if we decrease temperature, we'll increase density. In terms of salinity, if we increase salinity, we're going to increase density. We can increase salinity in a variety of ways. We can do that by either adding salt, or more commonly in the ocean, by taking away fresh water. Fresh water is removed from the ocean by two main processes. Those are evaporation and the formation of sea ice. So we're going to look at how deep water currents form, those density-driven currents. So the first factor that we'll look at will be temperature. So the setup that we've got here has a hot plate on one end representing our warm equator. That side of our container is going to represent the side of a continent dropping down into the ocean, that continental shelf on the equator. On the other side, we have bags of ice. Those represent our cool polar oceans. So we've got a miniature ocean. So deep water circulation, I want you to watch what happens as we add a drop of blue food coloring at our cold polar regions. Notice where that food coloring moves, whether it goes to the bottom or the top, the speed at which it moves, and also what direction it moves. So in a second we'll see it start to move in a particular direction. So if you look closely, you'll see that the blue food coloring is moving along the bottom towards our equator. So it's moving along the base of the container. Now we'll add a drop of red food coloring to our equatorial side. Watch for the same things in our red food coloring. We want to see whether it travels along the top or the bottom, how fast it's traveling, and in what direction. Right now, you're seeing as the blue food coloring encounters that continental shelf, it begins to rise up. That's a process we call upwelling. It's carrying nutrients with it. So if we look at our red food coloring, we can see that it's flowing in the opposite direction from the blue, and that it's flowing above the blue. We can explain that difference through density. So watch again. You'll see that the red food coloring flows along the surface, whereas the blue food coloring flows along the bottom, and they flow in opposite directions. Right now they're crossing over each other. You're seeing the blue on the bottom, red on the top. Think about what that means in terms of density.